Now we're going to learn how to calculate stream gradient. And this formula for calculating gradient is on page 62 of the lab manual. So the first thing is to talk about the planimeter, or the measuring wheel. So you can see that we have one of those right here. All right, and what you're going to do is you're going to use the planimeter looking at the white face as opposed to the yellow one. On the white face, you'll notice that it has inches on the outside of the dial. You notice it has a black wheel over here and then a silver wheel on the bottom, which you can see makes the needle move. Alright, so we're going to use the planimeter to measure the distance of the stream in inches on the paper map. And in order to make sure that you have this wheel calibrated, you want to make sure that you have a zero, any one of the three zeros. Actually, there's a lot of zeros. There's more than three. But you need to have zero in the window here with the black dial, and the needle needs to be on 36. And when you have that, you are ready to use the wheel. Okay? Alright. So let's go ahead and look at how you calculate stream gradient. So we have here the gradient, which is given in feet per mile, is the difference in elevation, also known as the rise, and then divided by the horizontal distance on the map, known as the run. Okay, so let's go ahead and see how you do this. So I'm going to create a stream. Alright, and I'm going to add some contour lines. Alright, so the contour lines, as you know, create V's when they cross the stream. I'm going to put some elevation values on here. Alright, and these are in feet. Alright, so let's say that you are asked to calculate the stream gradient from point A to point B. Alright, so the first thing we're going to do is look at the change in elevation between the 2 points. So that's going to be the what we call the rise, or the change in elevation. Alright, so this is basically a slope calculation, rise over to run. Alright, and then this will be the distance, and that's known as the run. And that's what stream gradient is. Okay, so now let's look at the rise. So the change in elevation, you're going to take the highest elevation of the 2 points, which is 500, and then subtract the lowest elevation of the other point, which is 100. Okay, and then from that we're going to get 400 feet. So 400 feet is the rise. Okay, now let's go ahead and calculate the run. So that's when you take your planimeter, and you want to make sure that you're using this wheel correctly. You want to make sure that the needle moves clockwise as you're measuring across the map. So in order to do that, I recommend that you hold the planimeter in your right hand and move the wheel towards your left shoulder. And if you use it that way every time, that will ensure that the needle is going in the correct direction, which is clockwise. Alright, so what you're going to do is you're going to put that little silver wheel on the bottom down on your starting point, and then you're going to trace out the path of the stream. Alright, make sure that when you're doing this that you're watching that needle also to make sure that it's moving, because one of the problems you're going to have in lab, because the maps are laminated, is that sometimes this wheel will slide across the laminate. So make sure that if you have to, bear down so that that needle is constantly moving as you're moving that wheel across the map. If not, you need to either bear down harder or grab another planimeter or a measuring wheel. Alright, but you're going to basically trace out that path of the stream. Alright, as best as you can, try to be as accurate as possible. So you're going to follow that, make sure your needle's moving clockwise, and then when you get to the second point, you're going to take that off of the paper, and then you're going to look at how many inches you've measured. Okay, so let's keep the math easy here, and let's just say that we pick up our measuring wheel and we see that it's on 4 inches. Okay, so now we know that this map is not 4 inches in the real world. It's only 4 inches on the distance is not 4 inches in the real world. It's only 4 inches on the map. So what we need to do is to figure out how many inches this is equivalent to in the real world. So all the maps that we have been using so far, or all the maps that we always use, have a 1 to 24,000 scale. That's the map scale. So that means that 1 inch on the paper map is equivalent to 24,000 inches in the real world. Alright, so what we need to do then is we need to take the 4 inches that we measured on the paper map and multiply that by 24,000. Okay? And I'm going to take the calculator here so I don't make any mistakes. Alright, so 4 times 24,000 equals 96,000 inches. So that's how many inches it is in the real world. Alright, but now remember, the gradient has to be in feet per mile. So we need to convert this distance between the 2 points from inches to miles. Alright, so we know that 1 mile is equal to 63,360 inches. So that's the relationship between inches and miles. So what we're going to do is we're going to take this 96,000 inches and divide it by 63,360 inches. That way we get rid of the inches, and then we'll be left with the miles. Okay, so we take the 96,000, divide it by 63,360, and we get, rounding that up, we get 1.5 miles. Alright, so that's our run. So we go back down here, and we have 1.5 miles. Okay, so we'll do this math right here to get the final answer. So we'll do 400 divided by 1.5 equals, rounded up to a whole number. So since we got 266.6, we'll round this up to 267 feet per mile. And that is the stream gradient. So that means that for every mile you travel on this stream, the elevation is going to change by 267 feet. And that's how you calculate the stream gradient. Remember, you must start and stop on a contour line. And if the contour lines are not crossing the stream, then technically you can't calculate stream gradient. So make sure that the gradient or that the elevation values that you're using, the contour lines associated with those values, are the contour lines that you start and stop on. Okay?